Welcome dear students in MSc second organic chemistry class. In previous lecture we draw the Newmanns projection for Cis and Trans Decalin system. In today's lecture we again draw the Newmanns projection for Cis and Trans Decalin system, but by changing the carbon numbers. So see, first of all, the Trans Decalin system. The Trans Decalin system in simple form we can write in this way. So this dot represent upward direction hydrogen. Suppose instead of in previous lecture we given the number as carbon number 1 for this carbon, but in today's lecture we start the numbering from this carbon as a carbon number 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. For more understanding, we try to change the numbers and how will be the structure in Newmanns projection, that we have to study here. So in chair conformation, in chair form, the structure is like this. Only we change the numbers. So this is carbon number 1, 2, 3, 4. This is 10, 5, 6, 7, 8, 9 and 10. So carbon number 10 have upward direction hydrogen and carbon number 9 have downward direction hydrogen. So this is A ring, this is B ring, this is A and this is B ring. So in this way you know that the chain conformation can be drawn, but important thing is the Newmanns projection for this Trans Decalin system. So while writing the Newmanns projection we must consider the front carbon atoms for this particular system. Carbon number 9, carbon number 9, carbon number 8 and carbon number 7. Carbon number 9, 8 and 7. These are the front carbon atoms. So, while writing this Newmanns projection, I first of all draw here the first dot which represents the front carbon atom, the carbon number 9. The front carbon atom, that is carbon number 9, this carbon atom. This carbon number 9 having axial downward direction hydrogen like this. Its backside carbon is a carbon number 10. Backside carbon is a carbon number 10. Carbon number 9, left hand side is connected to next carbon, that is carbon number 8, which is connected to the carbon number 7. So 9 is connected to 8 carbon, 8 is connected to the carbon number 7 like this. So this is carbon number 7. This carbon number 7 have axial hydrogen, equatorial hydrogen, axial hydrogen and equatorial hydrogen. Similarly, next carbon, backside carbon of carbon number 7 is carbon number 6, having axial hydrogen and equatorial hydrogen, axial hydrogen, equatorial hydrogen like this. So 6 is downward side, from right side it is connected to next carbon atom, that is carbon number 5, which is connected to the carbon number 10 likewise. In this way. So carbon number 9, we arrive at this carbon number 9. This carbon number 9 is also the front carbon atom for B ring. So 9, 1 and carbon number 2. These 3 carbon atoms are the front carbon for B ring. So 9 is connected to carbon number 1, which is connected to the carbon number 2 like this. The backside carbon of carbon number 2 is a carbon number 3. This carbon number 2 have hydrogen, axial hydrogen, equatorial hydrogen axial hydrogen and equatorial hydrogen. The carbon number 3 also have these two hydrogens, axial and equatorial hydrogen, and this carbon number 3 is downward direction connected to the carbon number 4 in this way, like this, like this. So in this way we can draw the Newmanns projection for the trans decalin system. The important thing is related to the energy content. Energy content. When we consider the trans decalin system, the energy content of this conformation is found to be 0 kilocalorie per mole. Our expectation is that the energy content must be near about 0.9 kilocalorie per mole, because if you remember the equatorial trans 1,2-dimethyl cyclohexane, then its energy content is found to be 0.9 kilocalorie per mole. This structure, this conformation having energy content 0.9 kilocalorie per mole, and our expectation is that its energy content must be near about 0.9 kilocalorie per mole, because it is similar to the equatorial 1,2-dimethyl trans conformation, but this is a closed system. This second ring, this B ring, is total closed system, and therefore the energy content is nullified and it is considered as a 0 kilocalorie per mole. Okay. As energy content of this conformation is found to be 0 kilocalorie per mole, it is more stable. Now let us consider the Cis decalin system. In Cis decalin system, we know that either two hydrogens on downward direction or upward direction, or both hydrogens on downward direction. So in yesterday's lecture we observed that the decalin system, Cis decalin system, can be drawn in this simple way. Okay, so in this way we can draw the decalin system. Okay, let us consider the change in numbering. So I start the numbering as 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. For more understanding, suppose we consider this second conformation 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, in which both hydrogens are downward direction and both hydrogens are on downward direction. So in this structure we easily observe that both hydrogens, these joining carbon hydrogens, are downward direction. So next carbon, this is carbon number 1, 2, 3, 4, this is a 10, 5, 6, 7, 8 and this is a 9. So in this way we can draw the chain conformation, but latest important thing is that the Newmanns projection, again we came across the point, that is the front carbon atoms which are present in A ring. In A ring carbon number 9, carbon number 8 and carbon number 7 are different carbon atoms. So first we consider the first dot that represent the carbon number 9. 9 having this downward direction hydrogen. 9 is left hand side connected to the carbon number 8. 8 is connected to the carbon number 7 like this. So 7 having axial and equatorial hydrogen. Likewise carbon number 6, which is the back side carbon of carbon number 7, having these two hydrogens, axial, equatorial. Back side carbon number 6 having axial hydrogen, equatorial hydrogen. This carbon number 6 is downward direction connected to the next carbon atom, that is carbon number 5. This carbon number 5 is next connected to the backside carbon of carbon number 9, that is carbon number 10. Carbon number 9 backside carbon is a carbon number 10, which is connected to carbon number 5. Okay, so let us look towards the B ring. In B ring, we observe that carbon number 9 is a front carbon atom, then carbon number 1 is a front carbon atom, and carbon number 2 is a front carbon atom. These three carbon atoms are the front carbon atoms. So carbon number 9 in equatorial position, upward direction, right hand side, having this carbon number 1. This carbon backside carbon, that backside carbon of carbon number 9 is carbon number 10. This carbon number 10 have axial upward direction, carbon number 4, downward direction equal position, have this hydrogen. This carbon number 4 and carbon number 2 is connected to carbon number 3. So carbon number 1 is connected to carbon number 2 and carbon number 3. So carbon number 1 is a front carbon atom, carbon number 2 is also front carbon atom. 1, then this is carbon number 2. So front carbon is represented by this third dot. So carbon number 2 having these two hydrogens and its backside carbon is carbon number 3 having these two hydrogens and connection with the carbon number 4. So in this way we can draw the cis decalin system. Very simple way we can draw the cis decalin system. But this cis decalin is slightly unstable, less stable than the trans decalin system because of the energy content. Remember the energy content of this conformation. When we observe this conformation, then when we look towards this Newmanns projection, in Newmanns projection also we observe that there are three gauge-butane interactions observed as C8, C9, C1 and C2 carbon. First gauge-butane interaction, C8 means carbon number 8, C9, C1 and carbon number 2. This is the first gauge-butane interaction. Second gauge-butane interaction is observed as C8, C9, carbon number 8, 9, then 10 and 4, 8, 9, 10 and 4, 8, 9, 10 and 4. The second gauge-butane interaction, and last third gauge-butane interaction is observed as carbon number 6, 5, 10 5, 10 and 4. 6, 5, 10 and 4. So these three Gauss interactions clearly observed in Cis Decalin system, which are totally absent in Trans Decalin system. Therefore, the energy content of this conformation is found to be 2.7 kilocalorie per mole, because each Gauss interaction having energy content 0.9, so 3 into 0.9, it becomes 2.7 kilocalorie per mole. This much amount of energy is associated with the Cis Decalin system, therefore it is very unstable than the Trans Decalin system. Okay, so this numbering, these Gauss interaction numbers get changed with the change in the numbering of carbons. Means one, suppose I have given number as 1 here. If I change the structure and I given the number as 1, then the number of Gauss interactions are same, 3, but the number gets changed, and these 3 Gauss interactions are responsible for the creation of energy content 2.7 kilocalorie per mole. Okay.